for the introduction. All right, I definitely don't want to go first, but
You're not given a choice, yeah?
I love laying out, so, but that's fine. Thank you for the opportunity to give a talk. So thank you, EB and Dr. AIIFC. My boss is here. Most importantly, my students are back there, so that's my most important audience. All right, so I use this. Am I supposed to be in the thing?
Yeah, Chris is going to follow with the camera.
All right, so given 30 minutes, is that right?
Yeah.
So one of my issues is I keep going, so you need to stop me.
Yeah, I will stop you.
I'll try to give you a talk in the following section. Briefly introduce natural language processing. Those people who are very familiar with it, this is probably very, very basic. And then I'm going to do a little bit of a survey in finance people using the natural language processing. And then I'm getting down to specific detail about how some of Python packaging, some of the machine learning algorithm break down the text information to digest so that we can have a better understanding of it. And then, of course, there's a debate going on between understanding textual data. Is a human approach is better because of humans has the most advanced way, as opposed to machine learning algorithm might be the next better way to understand the text information. Some of the challenges that I'm going to introduce. Now, this used to be the challenges probably about 2 years ago. Even after 2 years, it's so much advancements going on in NLP and machine learning algorithm. Maybe this challenge is not a challenge anymore, so something that I can share with you. And then some of the recent development in the financial literature and the future research. Okay. All right, so I guess this is not a machine learning algorithm class, but you can break down the machine learning algorithm into supervisor, unsupervised, and deep learning and so on. Supervised machine learning is using labeled data with classification, algorithm, regression, and decision tree and so on. And then you go to clustering with unsupervised machine learning algorithm. But as far as textual information, I think our focus is on maybe deep learning part. So all the popular topic you guys talking about ChatGPT is about transformer model, and BERT model produced by the Google is the summary over here. So it's heavily data-driven algorithm. But here we're not trying to understand just specific nature of algorithm. This is not a computer science. This is a physics school, and we're talking about financing here. So I try to focus on how finance people in social science and engineering area borrow techniques from, say, science and engineering, which is across the street, and understand some financial problem. I'm sorry, maybe this is not very visible, but one of the heavy main topic in finance, as you can see, is that one umbrella within finance is asset pricing. So that's the fancy way to see picking the winning stock, such as NVIDIA, such as Tesla, maybe. The valuation is a big issue. So nowadays, the reason why we have so many papers out there about finance and machine learning, I scanned about 5,000 papers, but it's not just done by finance people, because this is all money hungry people try to beat the market using some active strategy and with a concept from this machine learning algorithm. So you can see that this list of financial literature in 1990 and 2020. I'm sorry, you can see it very well, but it's almost about the investment analysis, valuation, price prediction of the futures and options market pricing, and the credit decision, and so on and so on. Still, there was a main issue in 2020. But what I see is now is the AI in finance and credit risk forecasting, and on the top is a sentiment analysis. So perhaps sentiment analysis is a main driving engine in finance using machine learning algorithm. So maybe I give you a little bit of a naive example on the sentiment analysis. So according to this paper, they scanned about 5,900 paper. Again, not just by finance and the computer science people, linguistic department, statistics department, or those things. Okay. So where's the natural language processing? Well, you have seen the diagrams a lot, so NLP is a part of AI, okay? But the main thing is we have unstructured data. So if you read a typical textbook, okay, we have students read is just a structured data in the sense that it's a perfect, grammatically correct English sentence, as opposed to you guys are doing Twitter. Maybe Elon Musk is doing Twitter and Donald Trump is tweeting. All the message is, especially for me, like coming from the non-native speaker of English, some of the English is like, what? What is he talking about? That's very unstructured data. And even if two people say the same thing, depends on their cultural background, their nuance. Okay, those data is not really consistent. Okay, even if we're talking about the same sentence. So the challenge here is that we have unstructured data, try to convert into the more meaningful way that or more basic form so that machine can understand. I mean, we can understand Shakespeare's or the novel and everything, but machine understand only binary, right? 0 and 1. So somehow we have to convert for those unstructured data with the machine learnable data. So there's a different name for that, okay? So I guess we are academics, I'm academics, but some of the audience people might be some practitioners. Then some of the business practice we can think about using NLP is a sentiment analysis. So my wife is shopping at Amazon.com. She's looking at the positive comment, the negative comment. That's a sentiment analysis. You're putting things in eBay auction. There's positive and negative comment. Okay. So you can scrape in those data. How about Yelp? Evaluating all kinds of food and restaurants. There's a sentiment analysis. Tax classification. We have an expert in the medical record. Tahir is going to talk about maybe medical record or the legal document. That's the immense amount of textual information. We're trying to extract those information. How about Alexa? How about Google's voice search? And text extraction, same thing. And the transform model is originally developed, as far as I understand, as a machine translation from English to German, English to something else. And then urgency detection. One example would be, I'm from some country in the mysterious country in the Far Eastern Asia. It's called Korea, and that one of the dark side of being a Korean is that the suicide rate among the young folks is very high. Now, I'm not going to get into the cultural side of Korean or anything, but there's an urgency detection. It's like, all right, there's a certain area that's high rate of suicide, and then before people are doing anything bad, there's a certain message board that they can put into. They automatically go into the 911. Depends on the context. There's a 911, people can react to that kind of textual information. So interesting stuff going on. But as far as the finance literature goes, we try to focus on sentiment analysis. Okay? So some of the data set that are unique to asset pricing or corporate finance or finance in general is a social media data. So there's some paper about Twitter, messaging, and then try to relate to asset valuation. Newspaper, corporate filing is big. Okay. I don't know if you guys ever visited the Security and Exchange Commission. There's an EDGAR database, has all the 10K annual report and quarter report. I think yesterday, Microsoft and Google's earning was fantastic and stock went up like 12% and 5%. And especially what we try to understand is management usually express their future guidance. For example, Microsoft thinking their OpenAI division is going to exceptionally well, then that's going to be a positive signal to the market. And reading those discussion analysis by machine and then digest into the trading platform is probably one of a major trend in trading and asset pricing area. Conference call is another one. Federal decision, Federal Reserve Bank decision, and all the analyst report as well. So since this title of this talk is the literature of finance, utilizing textual information. Some of the paper that I found is that, again, here Twitter message has some BDASK information symmetry of context, and higher Twitter sentiment of Fed is related to the index return. It's not directly related to this paper. It's not about the finance, but I found this very interesting. So here's your machine read, or his researcher read some of speech and text information done by the Republican Party. They are mainly focused on unintended consequences of regulation. So the Republican is usually like the left regulation. And so both the Democratic parties maybe put the more social value on equity or gender equality and also the diversity and sources. So that's something you can capture with the machine as well. And financial statement as a text. Interestingly, some of the paper looking at here, machine read this NDA, management discussion analysis, and then they can find some fraudulence. It's not directly illegal, but more like hiding information. The conference call, as an example, financial statement. So nowadays, how many of us is trading stock or investing in real world using real money? Actually go to the SEC document, read the financial statement. I mean, I don't. You could, okay? I don't have time for that, okay? Especially you have like 120 pages. It's all the mumbo jumbo. By the way, another paper I found that this is interesting. The size of this financial statement is a double. So I guess one cue you can use if you really greedy about stock market is that if they have like 120-page long annual report, that's the stock you want to do short sell instead of you want to buy. Okay, maybe. Okay, so that's something that interesting thing. So I guess one of the messages that I'm sending to the audience is that, of course, again, under academics, it's not so much here about the profit generating motive. It's more about understanding how corporations behave, understanding textual data to see if there's any economic and meaningful link between data and those behavior of the firm or asset class. Okay. So I'm going to just skip this one. All right, so for those people who are the first time ever done so-called sentiment analysis, okay, this is a little embarrassing, but I'm just giving my simple personal experience. So as a teacher, at the end of every semester, I'm getting lucky students, right? So sitting in the back there who always come to the class, they love my lecture and saying, this is the best teacher, that's the teacher ever, okay? This is the exceptional teacher, that's really positive comments, right? But, every semester, I'm getting some students who are not very satisfied with the way I do in the classroom, say that, I'm a useless teacher. So I feel that this is a simple, naive sentence, obviously extremely positive, extremely negative. Any human being say, all right, that's like a 9 out of 10, that's positive. This is maybe 9%. So we feed it into the Flare. Flare is kind of a word, the Python library, and also I use the transformer model as well. So this is a simple, like a 5-7 line. We categorize it 0.99, positive, 0.99, and negative. That's the core idea, okay? Now, before finance people who are very conservative, shy away from using what the computer science people say we have to, we say, no, we do our own thing. Then this is all the humans are doing. This is all human approaches that are right, recommend the better. Okay, that's positive. So you kind of counting. Okay? That's like a very primitive way to do that. And so suppose this machine learning actually using deep learning algorithm can capture those things much better, right? Now that's just an anecdotal example, okay? So more related to finance. I found this article in somewhere, and the GitHub. Basically, this article is saying that, okay, using beauty pursuit, if you don't know what the beauty pursuit is, they're web scraping, okay? About this very popular financial media and capturing the textual information. And then line by line, they assign the numerical value from the 0 to 1, negative, neutral, positive. Based on this score, you can feed the execution, the trading execution is maybe, I don't know, Robinhood? Is that something you can do? I don't know, okay? So you talk about algorithm trading, and then you can generate some alpha. Now, first of all, don't try this at home, because if he or she can make money with this, he wouldn't say this in the public, right? And of course, I went to the AQR, which is one of the largest quant firm, okay, managing 125B. They say they're using machine learning algorithm for their trading platform, but they never say about the specific algorithm of trading they employ, right? That's their business secret, which is not public to us. So we don't know for sure they're actually generating meaningful Sharp ratio or meaningful alpha. But this is what the example is. Okay? So I guess this is how many more minutes I have?
We have 5 more minutes.
Okay, so 5 minutes. All right, so see, this is the problem. So breaking down, maybe 6. Okay, so breaking down this I can do this. Okay. Okay, basically what it's doing is this, right? Using the Python, basically Python algorithm, okay, you have let me show you this one, okay. Suppose that this is a board of a governor, okay, doing the speech, okay. Now that's the textual information. So he has like about 5-page long speech. And then basically Python algorithm that I just showed you earlier is a breakdown into each single word, okay. And then there's lots of cleaning. First of all, you make a capitalized word in the lowercase, and then say economics, economy, economical is kind of coming from same origin. So you kind of condense to the one word, is a stemization, lemmatization. And then you're removing all those stop words. What do you mean stop word? I, he, or he, is. That's the some word that is not much meaningful, but inflation, concern about mortgage market, that's a very important word. So those capturing those important words and putting the word crowd. And then you assign positive and negative. And then you kind of conclude by looking at the textual information coming out of Python engine and say, yeah, his main talk is about inflation, mortgage market. And he's very concerned about the inflation perspective, which he did about 2-3 years ago when suffering and inflation. Okay, so I'm going to skip to this, and then I'm going to introduce, what's the role of machine learning? Okay, so back in old time. Now, when I said old time, I'm not talking about 20 years ago, about 5 years ago. Okay, and then we just basically had the humans come in and they classify word into positive and negative. So linemen come to the tennis court and say, okay, this is in or out. But now we're using the machine and making a call. So that's how fast things go in the last 5 years. And this is all kinds of machine learning algorithm, but texture data is heavily suggested by here in the CNN, long short-term memory, and then RNN, and then transformer, and that's the thing. Yeah. Is that somebody talking?
No. The machine. I think it's
Machine learning.
sound.
Okay.
Yeah.
So according to this paper, all right, I thought that this is a pretty interesting data that suggests, so OLS is also part of the machine learning algorithm, but you can see that here's an Y is the actual, and then here's a prediction. So as there's the dot clustering through the straight line, there's more prediction error. So what's the difference between what the economists and finance people did in 5 years ago? We try to understand the association between X and Y. Is that education has any association with wage? That's the association is the main highlight of economists. As opposed to now machine learning is all about prediction. as far as the prediction goes, you can see that the predictability is very high. Okay, especially if you look at the outlier part, it has something that they're doing exceptionally good job. So, as economists, as a finance people, this is something we have to think about. Economists, finance people always say outlier. Okay, drop it. Yeah, outlier, we winterize it. Okay, all right, and then we look at if you go to State Department, they're going yelling at you, saying, "Hey, outlier is still data. It's a genuine data. You have to do something about it instead of just dropping." So there's some philosophical difference right here. Okay. So I'm going to skip through this. So one of now, the highly cited paper using machine learning algorithms. So this is Dr. Kelly in Yale, and he's also head of machine learning algorithm in the AQR in Hong Kong. And basically, I'm sorry, there's so much going on here, but basically they're using the supervised machine learning algorithm. And then, doing the textual information breakdown into negative and positive word. And then they argue that top 50 start with the positive sentiments, okay? And showing the 50 start with the lowest sentiment, they create the R, a Sharpe ratio of 4.29, which is handsomely beat the market portfolio. Again, this is what they say, but the detail. I mean, when you do the supervised machine learning, I want to know what kind of parameter they're using. How do the feature scaling? How do transformation? We like to know. Of course, all those things are not really, available. Yes. All right. So since I have 1 minute, yeah.
2 minutes.
2 minutes. So we have some of issue in awards, say like 3 years ago. Look at this sentence. And then, those people who kind of very shy about using the machine learning algorithm or against using machine learning algorithm say, all right, here's a sentence, say, I saw the boy on the beach with my binocular. Is that meaning that I saw the boy with the binocular or I used the binocular to see the boy, okay? Now, as a human being, we can easily capture the nuance, but machine could not catch the difference between those two things, okay? But that was 3 years ago. And then what happened? Okay, I'm gonna keep going here. And then what happened is, sorry about that. This paper in 2017, okay? This is a pioneer paper, 2017 by Google. I don't know, maybe you guys have heard of that. So if there is a Nobel Prize given to machine learning algorithm, maybe this is, I don't know, okay? But then they just blew everybody's minds using transformer. So now here's interesting. This is a paper just revolutionized the transformer model, okay? And then exceptionally doing good job. Even those, I saw the boy with the binocular easily because the transformer model look at the, those words before, those words and after, and they try to measure interaction of a word before and after, and they catch the almost human, kind of a nuance. But developed by Google on OpenAI used their model, and they put the ChatGPT, and the Google model was not as good. But I think Google is coming back in some sense, okay? But they're the original developer and this. So this is one of the improvement. Improvement, if you look at this, I'm sorry. Okay. So have you ever done here's one example of Googling before transform model. Say, can you get the medicine for someone in pharmacy? So I need my own drug, but I'm sick at home, so I'm going to ask my friend go to the pharmacy and pick up the medicine. Before transform model, is getting a prescription filled, medicine plus, oh, that's not what I'm looking for, right? Because I'm trying to see whether or not I can have another person who is not matched with my name can get the drug for me. And then after transform model, is can a patient have a friend or family member pick up the prescription? This is what I want. So transform model catch this very delicate nuance, and then that's the revolutionary ChatGPT. So So, you probably see that there's a history of a transform model comes in 2017 paper. Ever since then, all the large language model come in and the GPT using 175 billion and the GPT-4. Related to that, I guess this is my last paper that I'm going to share with you. So I found this paper about 2 weeks ago. They updated on April 14, 2024 from University of Florida. So this is the eye-catching paper, right? ChatGPT, they're predicting how stocks will react to new headline. What was interesting about the paper found is that when the manager is trying to hide the information using the ChatGPT, using all kinds of conference call and all the data, they can successfully identify that kind of nuance and use their exit pricing trading and create the sharper result. Now, we don't know if this paper is going to publish in the good journal or not. There's a judgment call is coming, but I think that that's the recent development here. One last thing that I want to share with you, a lot of people in this field are heavily interested in say asset pricing, but the other side of finance is corporate finance, how the firm behavior, looking at the firm characteristic, look at the balance sheet, income statement. I think that that's the new area of the research item because some of us is interested there. Okay, so I ended this talk.
All right.
And
If there are any questions, Hi, Matt. Are there any questions online or no? No. Any questions here from the room?
yeah,
Thank you for your talk, Professor Yu. So one quick question. There was a paper called Predicting Returns with Textual Data that you talked about.
yeah.
Do you know what data source they used to predict the returns?
I think they use like the Edgar database information.
Okay.
Okay. Yes. But if not, then I take a question.
Okay.
Yeah.
Thank you.
Any more questions?
No? Okay. All right. We can.
Yeah, just a quick one. So, from this ChatGPT and using it to beat the market, just, I guess, big picture, it is mining data that is already there, that information that is already there. It's kind of like using theories that we already created.
Mm-hmm.
What if those theories are wrong? So, what if you're training a model on something that we used to believe, I don't know, for the last 40 years, and then tomorrow somebody comes up with a new theory that actually explains the stock market.
Yeah.
And all this trading data that we have for 40 years is just random stuff.
Yeah. So I think that is related to the debate going on is that you always have a training set and the test data set and validation data set. Now you have your machine learning algorithm training with the training data set, well, maybe things have changed and the training data set does not capture the delicate part of test data does not capture the training part. Maybe there's some error function that might be huge, then maybe model collapse. But I totally understand. I'm not saying this paper is the paper that pioneered the asset pricing algorithm, but this is the most recent one that catch the eye, and the people probably debate about same issue that you suggest. But of course, if you start with the wrong model, garbage in, garbage out, and obviously. Yes, sir.
Economists we like to think or think in the framework about animal spirits. But
Yeah.
what about if this is so perfect that it's going to be guiding you to the right purchases?
Okay.
How is that animal spirits going to behave in the future, in
So-
your view?
You're talking about behavior finance as opposed to maybe efficient market. Okay. So this is one of the strengths of machine learning algorithm is that it's training for so much data.
Yes.
Okay. And then hopefully those animal spirit and machine learning, behavior bias that make stock price deviate from true intrinsic value or not. If you have so much data, I don't know, it's a randomly, it's a zero sum, I don't know. Okay. That's a good question, but it's not, okay, machine is capturing the personal bias in one way here, or what? I have to.
So you have to talk about herding behavior, et cetera.
Any questions?
Yeah, I mean, this is really interesting. And I'm also reflecting on the previous comment on what happens to theories that are now being invalidated with new models. I guess the flip side of that is who cares about theories now, right?
I do.
I think, so in other words, you're kind of flipping the traditional model of how you probably would want to set up a conceptual framework and establish hypothesis and see if you're able to validate or not, as opposed to just data driving whatever predictions that you want to make decisions. So in some sense, the balance, I think, perhaps is being shifted or will shift. Not that I have any clairvoyance on any of these things, but just seems like it's because of the computing power as well as the ability for creating vast amounts of data that theory would probably call them outliers or not relevant becomes marginally contributing to predicting behaviors of.
So I have a comment on that though. See, back in 20 years ago, 30 years ago, when I was a PhD student, I went to the stat department and applied the statistics 101 with the stat people. And they kind of make fun of this economists and finance people saying that if you're running data and then your outcome is not what you expected. And then they say economists think that data is wrong. Okay. And because stat people always just rely on data only. They look at try to see the pattern from the data without thinking about prior. Okay. But we social science people in finance and econ, we gotta have some rigorous theory that backing up the your hypothesis, and then you testing your hypothesis. So I guess that's the philosophical difference. Okay. I mean, say, Federal Reserve will raise the interest rate and it's going to come down the money supply. That's the theory. I mean, we strongly believe that. And you ignore that you're just running the data. I think that's data mining. So, yeah.
And maybe to back up what you just said, when economists are finance who develop economic theories, we're making some kind of assumptions. And some of those assumptions might not be purely plausible. Milton Friedman wrote about data.
Yeah.
It's not the plausibility of the assumptions put in a model, but rather the model's predictive power and outcomes.
Yeah.
So maybe machine learning can actually help to maybe, straighten up, the implausibility in the assumptions we put in the model.
That's good. Yeah. We have already a strict assumption, right?
Yeah.
FM is not working, people will relax assumption. Right?